Right. Good evening, everyone. Welcome back to the session on communication systems. Yesterday we have discussed what are the topics that you will be getting in your exam, means the syllabus point of view. And then I have discussed some questions related with the amplitude modulation schemes, frequency division multiplexing, and questions related with angle modulation schemes. Okay. One or two more questions are left over in angle modulation schemes. We will complete that today. And then I will discuss questions related with random variables and random process, which is a very important topic. And then depending on the time frame, I will also discuss pulse code modulation scheme. Okay, so that would be the session for today. So let us start from where we have stopped yesterday. A few questions are left over in angle modulation schemes. First I will discuss those points. See here, an FM signal with a modulation index 9. So what do you mean by modulation index in FM? Means he is saying the value of beta becomes 9. E is applied to a frequency tripler. Frequency tripler means what? If you give input as x of t, output will be x of t whole cube. So the order of your nonlinear device, which we generally write as n, is 3. Then what will happen? The new value of beta will be n times the original value of beta. So this beta of 9 will now change to 27. Okay. Now what is the question he is asking? The modulation index at the output is dash, simply 27, finish. Direct questions which you can solve within a minute. It will take maximum 30 to 40 seconds, that's all. Okay. Right. Let us see one more bit under this logic. In an FM system, a carrier frequency of 100 megahertz. So he is talking about carrier frequency of 100 megahertz is modulated by a sinusoidal signal, means single tone modulation, 5 kilohertz. Message signal frequency is 5 kilohertz. The bandwidth by Carson's approximation is 1 megahertz. Means what is the meaning in that? 2 into the value of beta plus 1 into FM, which is your 5 kilohertz, is given to you as 1 megahertz. 1 megahertz means 10 power 6. Directly write this. And no need to use any calculator. You can see 2 into 5 becomes 10, 10 power 4. So 10 power 6 gets cancelled out. You will have 100 there. So the value of beta is 100 minus 1, 99. That's all. One step. Now what is he saying? If y of t is modulated waveform whole cube, means what is the order of your device? It is a nonlinear device of order 3. Then what will be the new value of beta? N times the original value of beta. So it is going to become 297. 97 multiplied by 99 multiplied by 3. And what will be the new value of carrier frequency? N times the original carrier frequency. So this is going to become 300 megahertz. 100 megahertz multiplied by 3. And what is the new value of your message signal frequency? This remains same. Message frequency does not change. So it remains at 5 kilohertz. So immediately these things should come into your mind. Previous question very easy to solve. This question, the model of framing the question is same, but little bit lengthy model. Okay. Now what is he asking? Then by using Carson's approximation, the bandwidth of the signal y of t around 300 megahertz and the spacing between the spectral components are dash. So what will be the bandwidth? Formula is same. 2 into, in place of beta, I am substituting new value of beta, which you got as 297 plus 1 multiplied by message signal frequency, which is remaining constant at 5 kilohertz. So this would be the value of bandwidth. So if you observe here, this is 10 power 4 into 298. So you can write this as 2.98 megahertz. Your options are given in terms of megahertz. So convert that into megahertz directly. So which will be your right choice out of the given? Either it should be option A or it should be option C. You can straight away eliminate this. Closest answer to 2.99 megahertz is 3 megahertz. So that's the reason I am going for this one or this one. Now what will be the spacing between the spectral components? All the spectral components in your wideband FM spectrum will be separated by a frequency of your message signal. That is nothing but your FM. So you take whether the carrier frequency as FC or new carrier frequency, which is n times FC. The spacing between the spectral components does not change because your FM is remaining same. So that means it will be 5 kilohertz. So your correct choice would be option A. So this is how you have to solve this model of questions. Definitely either this question or the previous question, the same model of question is expected in any competitive exam, because this concept is based on the triple R, double R, n value. So by using a narrow band FM signal, we generate a wide band FM signal, and then questions will be related with bandwidth. So this is how these questions will be framed. This method we generally refer to as Armstrong method or indirect method of generation of wideband FM signals using narrowband FM signal. Okay, so all this part is actually one topic that I have discussed using these two questions. So these are all the model of questions that you can expect in angle modulation schemes, both FM as well as PM, right? Now, let us take the next part of the syllabus that is given to you. It is under random variables and random processes. As I have discussed yesterday, you are having density distribution function properties, then autocorrelation function properties, power spectral density properties. So I have taken some questions which were given in previous papers and also some standard questions which are highly probable to get in your exam. And I am discussing all the topic related with that particular question itself. So try to understand these models, very, very important topic, right? See the questions. This is how the questions will be framed. Probability density function is given to you. So what do you mean by probability density function? It tells about the probabilities of occurrence of events in that particular random experiment. This is the data given. So your x is a random variable. It can take any value from minus infinite to infinite. This is a density function that is given to you. Now what is the question? He is asking what is the value of the constant k. So what is a property we have under density function? The total area under the given probability density function, that p of x, integral means area, should be always equal to 1. This is the logic we have to use. That means if you take a k outside, integral from minus infinite to plus infinite e power minus x square by 2 dx, value must be equal to 1, that's all. So using this property, we are finding the value of the constant k. Now how will you get this integral, because these are indefinite integrals. If you can remember the standard format, then you can do it, there is no problem. Otherwise, there is one simple logic. When you take a e power minus bt square, I am taking t as a function of time. The Fourier transformation for this is root pi by b into e power minus omega square by 4b. This is a very, very important standard Fourier transformation pair. Try to remember this, because most of the questions framed from signals and communications, there will be no paper which does not include this. Some way or the other, indirectly they will include this. Now, if you compare with your given function, what is your given function? Your given function is, in place of x, you just imagine it as t, that's all. Okay. Now, if you take that your given function is this value, which is like e power minus x square by 2. That means I am just imagining in place of x there is t. What does this property tell? If you want to take the total area of the time domain function over all values of time, area property of Fourier transform, what it tells is, take the value of the frequency domain function at omega equal to 0. So this value will be root pi by b, finish. So this is the logic we are using. So what I am doing here is, if my given function is e power minus t square by 2, then what should be its transformation? Means in place of b I am substituting 1 by 2. That means this value should become root, in place of b you are having 1 by 2. So if you substitute here, this becomes root 2 pi into e power minus omega square by 2. In place of b, just substitute 1 by 2. Now if you take the total area, e power minus t square by 2 dt, this will be the value of the frequency domain function at omega equal to 0, means it should be root 2 pi, finish. Now what is this value now? Just in place of x we imagined t, so k into the total area under this integral we got root 2 pi, must be equal to 1. So therefore the value of this constant k is 1 by root 2 pi, finish. Or if you are interested, you can compare the given function with Gaussian density function, still you can get the same answer. But try to keep these points in mind. They will be very useful in your examinations, especially time bounded papers. So all these things you should not do in your exam. You have to keep these points in mind. Immediately after this step you have to apply that. That is how you can save a lot of time in these type of examinations. Right. Let us see the next one. See here. Consider two independent binary random variables. So what is the meaning here? He is talking about two random variables, x and y. What is the data given to you? He is saying that these random variables are independent and also these are binary. Binary means what? It will take only two values. That is the meaning in that statement. Now, x is taking 0, 1 and y is also taking 0, 1. So, x takes values 0 and 1, it is a discrete random variable. Y also takes values 0 and 1, it is also a discrete random variable. Now, what is the data? Probability of x equal to 0 means what? P of x at x equal to 0 is P. Then obviously probability of x becoming 1 will become 1 minus P. Correct or not? I hope you are getting my point. Very simple to understand. Don't complicate the questions. Don't go into too many formulas. Especially this topic, it will test your skill set, how you are understanding the subject. Next, what is he saying? Probability of y equal to 0 means what? P of y at y equal to 0 is q. So the value of probability of y at y equal to 1 will become 1 minus q. Finish. Is it clear or not? Got it? Right. Now, what is the probability that x plus y is greater than or equal to 1? That is what he is asking. So what is this value? What is the probability that when you add x with y becomes a value that is greater than 1 or equal to 1? Very simple. When you add 0 with 0, it will be 0. When you add 0 with 1, it will be 1. When you add 1 with 1 also, it will be 1. Sorry, it will become 2. That means probability of x plus y greater than or equal to 1, we can also write as 1 minus the probability of x plus y becoming less than 1 or not. Reverse the condition. So when this will happen, x plus y when you add should be less than 1. Means obviously because these are binary values, only when x and y are 0 and 0, then only the sum will be less than 1. Even if you take one of the value as 1 or both values as 1, it will be either 1 or greater than 1. That means I can write 1 minus probability of x taking value 0 as well as y taking value 0. Finish. That means 1 minus, because you are given x and y are independent random variables, we can write this joint probability as product of individual probability. That means 1 minus probability of x equal to 0 into probability of y equal to 0. Finish. So this is a very important step. We can write that because you are given data that x and y are independent random variables. So 1 minus probability of x equal to 0 is p and probability of y equal to 0 is q. So that will be your final answer. So generally whenever these type of questions are given, they will give the value of p and q. Maybe p and q are 0.5. So 0.5 into 0.5 will be 0.25, 1 minus 0.25 will be 0.75. That will be your answer. So that is how these type of questions are framed. So try to understand the data. Don't worry about the entire set of questions. Once you see, you think that some different model is framed. Actually, it is one of the simplest questions. Just you need to spend little time, understand it and get it done. Right. Let's go to the next question. See this. The probability density function of a Gaussian random variable x is given. So what is the standard density function for a Gaussian random variable? 1 by root 2 pi sigma square e power minus of x minus mu whole square by 2 sigma square. Values of x can lie anywhere between minus infinite to plus infinite. So this is how we define the probability density function for a Gaussian random variable. So this is your Gaussian random variable. So that same data is given to you. So from here what we can assess, if you take 3 inside it becomes 9. So in place of sigma square, variance of this Gaussian random variable, it is 9. And if you compare this, the value of mean of this Gaussian random variable is 4. So these two things we can directly get it. So just by comparing with the standard Gaussian random variable, we will get these two values. Now, what is the question he is asking? The probability of the event x equal to 4 is dash. Now, if you sketch this density function, just for your understanding purpose, I am taking, say this is my axis. Now, you have your Gaussian density function with this particular shape, a bell-shaped curve, smooth curve. So, x-axis is your random variable x, which is a continuous random variable, taking any value from minus infinite to infinite, and this point, midpoint, whatever you are having, it's symmetrical about the mean. So, this is what is your mean, which is 4. So, let us assume this point is 0. So, this is what the data that he has provided to you. Okay. Now, what is the question he is asking? Be very careful here. What is the probability of x taking a single value 4? Now, here you have to understand that the given random variable is representing a continuous random variable. That is very, very important. Now, we can write this as value of the distribution function at x equal to 4 means what? It includes the sum of all the probabilities from minus infinite to plus 4 minus value of the distribution function just before 4 means 4 minus. For a continuous random variable, the value of the distribution function at 4 and the value of the distribution function at 4 minus both are same. That is a very, very important property of continuous random variable. Because your given random variable is continuous, the value of the distribution functions at these two places are same. So the value of the probability at a single point will be always 0. So your correct choice is option C. This is how you have to get it. The entire question is simply based on this property. Now, same question, suppose if he is asking, what is the probability of x taking all the values from minus infinite up to its mean? 4. Means what? You know the total area under the density function is 1. Now, because the density function is symmetrical about its mean, that is a very important property of a Gaussian random variable. Any Gaussian random variable will be symmetrical about its mean, means it's an even function about the mean. So, if you take the area from the density function from minus infinite up to 4 or from 4 to infinite, the values should be same. Because the total area is 1, if you take area from minus infinite to 4 or from 4 to infinite, the value should be half. That means this answer which you will get will be 0.5. Finish. So this is how you have to understand before doing this question. Now these type of questions are very tricky. Just instead of giving x equal to 4, if he keeps in place of equal to, less than or equal to, your complete answer will change. So student has to be very, very careful while answering these model of questions. It takes only time to read the question. Answer finding is seconds. Just whether it is equal to or less than or equal to. Finish. Now, whenever you come across the density function, you remember its distribution function also. Means P of x is its density function, probability density functions. For this type, the distribution function for Gaussian random variables is 1 minus q of x minus mu sigma. This is also very, very useful in your examinations. Q functions you have to understand. So whenever you have a random variable x, when you want to take the distribution function of a Gaussian random variable, then this is the standard format. Mu represents the mean, deviation. So these two things are very, very important. whenever you attempt any question based on Gaussian concept. Clear? So I am telling all the points related with the question, little bit on the question, whatever the points that are running around that question, so that all the topics related with this are covered here. So that is how I have planned these type of questions, and very very important for your competitive exam. No matter whether you are writing only this Polytechnic lecture paper or any other competitive exams, these model of questions are definite. Right. Let us see the next one. See here, for a random variable x, the following probability density function is shown. So here x-axis is your random variable x. Let us not take it as v, let me take it as x only. So on x-axis, this is a continuous random variable, and on y-axis you have its probability density function. Now what is he asking? What are so in they have mentioned it as moments. Moments are nothing but these statistical parameters: mean, mean square value, and variance. Now first find the value of k. How will you find the value of constant k? You know the total area under a probability density function curve is 1. So when you integrate this function from -1 to 3, which is given as k, will be equal to 1. So the value of this constant k becomes 1 by 4. Area of a rectangle is 1. Total area should be 1. Base is 4. Height should be 1 by 4. So that is the reason the value of this constant will be 1 by 4 over. Now, what do you mean by mean? Mean is nothing but expectation of a random variable, first order moment. So this x into f of formula. Okay. So what will be this value now? Integral x into f of x is 1 by 4 dx, and limit on x is from -1 to +3. Finish. So that y-axis is nothing but your f of x, which is equal to 1 by 4. So this value will be 1 by 4. X integral is x square by 2. X square when you integrate, it will be 9 minus 1. So this will be 8 by 8 equal to 1. So whenever you have a random variable of this sort, we call this random variable as a uniform random variable, because the probability of occurrence of all the events of x between -1 to 3 are equal. So whenever you have such a type of random variable, the mean value for such uniform random variables will be the midpoint. So what is the midpoint between -1 to 3? Exactly 1. 3 plus -1 by 2. So that is the reason you are getting the answer as 1. That is a shortcut. So whenever you get these type of questions, time bounded paper, so definitely examiner will choose these type of random variable. So you need not do all this calculation. Just by finding k and taking that midpoint, you will get it. No need to find even k also. Midpoint is your mean. Now next one he is asking is variance. Now your options are either it will be B or C, because both mean values are there. So try to find variance. There is no other choice for you. So what is this variance? Variance of a random variable is, first you have to find a mean square value. What do you mean by variance of a random variable? Variance is nothing but mean square value, means expectation of x square, we call it as second order moment, minus mean value of the random variable, means first order moment whole square. This is the formula for finding variance of a random variable. Now what will be expectation of x square? Second order moment is integral x square into f of x dx. Expectation of x, we call it as first order moment. All these are very clearly mentioned in your syllabus. I am touching all the topics with an example. This is what we refer to as second order moment. And whenever you refer to variance, this is called as second order central moment. Second order central moment. So these are different names. In terms of units, these are the names given. Now what will be these values? This will be 1 by 4 I am writing outside. X square integral will be x cube by 3. X cube when you integrate between minus 1 to 3, you will get 3 cube 27 minus of minus 1 whole cube 28. So this is 7 by 3. Finish. So what is this variance? This will be 7 by 3 minus 1 whole square, means 1 by 3 minus 1 becomes 4 by 3. Finish. So the value of mean or first order moment of a random variable is 1 and the value of variance or second order central moment is 4 by 3. So your answer will be 1 and 4 by 3. So this is how you have to calculate the statistical parameters for a given. Clear? So whenever you talk about moments, it's mentioned in your syllabus as moments. Moments means statistical parameters. It will be first order moment, mean. It will be second order moment, mean square value. It will be second order central moment, which is nothing but variance. Generally these are the three parameters. When you take the square root of variance, you will get standard deviation. Okay. So primarily on a single random variable, these are the moments that we can determine. Let's go to the next question. See here, this is also a very important model. Distribution function of a random variable is given. So your y-axis is distribution function. Always remember, small letters are density functions, capital letters are distribution functions. So sometimes examiner need not give this entire letter also, distribution function. So he may give x is a random variable with the following data. So capital letters always indicates distribution function, probability distribution function. Now, once you identify the data, try to understand the nature of the given random variable. So what is the nature of the random variable? You see the x-axis. Definitely it is not discrete, because discrete means what? It will have step model, complete step function. But here you can see there is a continuous function from minus 2 to 1. Sudden increase is there. That means there might be sudden change in amplitude or probability, and then again continuous and then becoming constant. So this is what we refer to as a mixed random. Combination of continuous and discrete is called as a mixed random variable. How will you identify? You can identify it whenever the curve has sudden changes in probabilities. So whenever you have this y-axis with this sudden step change, that is an indication of a mixed random variable. That is a very, very important observation. Now what is the question is asking? What is the probability of x equal to 1? Now previously I told you, if x is a continuous random variable, your answer, the probability, he is asking what is probability, means the value of a probability of x equal to 1 would have become 0. So if you see your options are also having 0, be very careful. But now the case is not that. The case is that your random variable is mixed. So how will we write? Formula remains the same. Probability of the event x equal to 1 is the value of the distribution function at x equal to 1, which includes all the probabilities from minus infinite to 1. That means what? Starting from minus 1 to 1, minus the value of the distribution function at x equal to 1 minus, means just before 1. Now see that value. At x equal to 1, how much we got? Exactly 0.55. Minus just before 1, how much we got? 0.25. So the difference between these two is 0.3. Finish. So your correct answer here will be option D. So I am trying to cover the properties of the random variable, which can take either the format of a mixed random variable, discrete random variable, or a continuous random variable. All this is very clearly mentioned in your syllabus. I am touching all the points given under random variables and random processes with a question. So previously I covered the property of only continuous random variable. This is a property of mixed random variable, and both are having equal chances to come in your exam. Strictly speaking, this is more important model, because easily student will confuse and will go for answer 0. So that's the reason I have taken this question. Okay, right. Let's see the next one. See this. Let x be a continuous random variable, so he is only telling with a density function. So some density function is given to you, x is taking values between 1 to 5. What is the density function of the random variable y, which is equal to 2x minus 3? So this is coming under the topic transformation of a random variable. Very, very important topic. So what we are doing here, we are converting one random variable x to another random variable y by using this linear transformation, y equal to 2x minus 3. Okay, so basically what will be given is, you will have input as a random variable x and you will generate a new random variable y. So this is my x and this is my y by using some transformation. So that transformation is given to you as y equal to 2x minus 3. So how will we do that? The density function of the new random variable y is equal to the density function of the random variable x multiplied by mod of dx by dy. This is a formula. You have to remember this. Okay. Now, what is y in terms of x? He has given it as 2x minus 3. So what will be dy? It will be 2 into dx. So what is mod of dx by dy? Value is 1 by 2. First get this. Now, when you take the lower limit of x, which is given to you as 1, what are the values of y? If you substitute x as 1, 2 minus 3 will be minus 1. So y will take minus 1. At x equal to upper limit, which is given to you as 5, what will be the value of y? 2 into 5 becomes 10 minus 3 is 7. That means whenever the values of random variable x is between 1 to 5, the random variable y is taking values between minus 1 to 7. This itself is a question in competitive exams. Based on the given transformation, you can tell what are the values of x and y. When x takes values between 1 to 5, your y is taking values between minus 1 to 7. Now what is its density function? F of y is equal to, f of x is x by 12. So 1 by 12 into, in place of x what we can write? Y plus 3 by 2, substitute that. Multiplied by mod of dx by dy, which is equal to 1 by 2. That means this will be equal to 12 2 is 24 into 2 is 48, y plus 3 by 48. And this is valid when y takes values between minus 1 to plus 7. That's all, over. So this is how we can convert one random variable x into another random variable y by using this type of transformation. So this is also one very important model. Chances of getting these type of questions is pretty less, but once the competition is very high, you cannot tell that only this model can come. Every chance is there for new questions to come in your competitive exams. Generally what happens is, depending on the number of applications they get, they will try to fix the level of examination, and that too you are going for a lecturer post, which is very, very important because you should be in a very good position to teach the students there. So generally they expect much more from you, and most of the students applying for this are at MTech level also, and some are even doing PhD or completing PhD also. So generally the awareness level of the students is also high, and you can expect every question. You cannot say that this is not from the syllabus or this is not the main part of the syllabus. Such things we cannot tell. Examiner has every right to keep the question paper at the highest difficulty level. So it is a part of the student, duty of the student to prepare at that level only. Then only you are eligible for that post. Keep that point in mind. So that's the reason I am telling you, please refer GATE papers at least 5 years. ECE communications. Even in instrumentation also you are having communication. So try to refer these papers. Examiner will not go above these papers. It may not be the same question that will be repeating. the model of the question remains same. So try to make use of that data that is readily available to you. Okay, right. Next, see this question. Intentionally I have taken this, 3 bits I have taken. See this question. The noise voltage in an electric circuit can be modeled as Gaussian random variable. GRV means it's a Gaussian random variable. It's a valid shortcut. That's the reason I have written here. With mean equal to 0 and variance equal to 10 power minus 8. Means what is the data? The mean value of this Gaussian random variable is 0 and variance of this Gaussian random variable is 10 power minus 8. That is the data given to you. That means if you sketch this density function, it's a Gaussian random variable with mean 0, means the density function is centered about its mean, which is equal to 0. So x-axis is continuous random variable from minus infinite to plus infinite. This is your midpoint 0 and this is your probability density function, small f of x. Finish. First sketch this, you will get a better idea of doing the question. Now what is the questions he is asking? You can get any of these bits in your exams. So that's the reason I have taken all the 3 bits. What is the probability that noise is greater than 10 power minus 4? So your x, whatever the random variable you are writing here, is actually given to you as noise n. So it is taking the form of noise. So instead of writing x, you can directly write n. So this is nothing but f of n. Okay. Now, what is the probability that x can take a value or n can take a value greater than 10 power minus 4? So what I am doing here is, I am taking some 10 power minus 4, it's a positive value, so definitely it will be on right side of 0. So let us assume this is your 10 power minus 4. So what is the probability that you will have a value of noise that is greater than 10 power minus 4? Means all this is shaded region or not? So he is asking what is the total area of that shaded region. So how will we write this? I can write this as 1 minus the probability of this n taking less than or equal to 10 power minus 4 as per probability definition. So this is nothing but 1 minus probability of n less than or equal to 10 power minus 4 is nothing but the value of the distribution function at n equal to 10 power minus 4. Finish. That means this is nothing but, I told you, distribution function for a Gaussian random variable is 1 minus q of, in place of that x is n 10 power minus 4 minus mean 0 divided by sigma, which is also 10 power minus 4. Finish. Sigma square is 10 power minus 8, so sigma will be 10 power minus 4. That means your answer will be q of 1. Finish. See how simplified your answer came. That means the total area under this function becomes equal to q of 1. So this itself is one bit in your competitive exam. Very simple question. So if you can draw the density function like this, then understanding it becomes very simple. Now see the magic. Because of the symmetry that you are having in these functions, the advantage which you have here is, if this is 10 power minus 4, its a symmetrical function on left side of 0 will be minus 10 power minus 4 or not? Correct or not? Now, if you say that this is from 10 power minus 4 to infinite, all this shaded region is from minus infinite to minus 10 power minus 4. That means the area under this shaded region would obviously be again q of 1. Finish. Now, can you tell what would be this area? The probability density function curve is 1. This is q of 1 and this is q of 1. So if you add this region area, 2 into q of 1. Subtract it from 1, that means the total area for this shaded region will be 1 minus 2 into q of 1. Finish. So if you can get one part of the shaded region area, all the remaining parts also we can get very easily. So that is the advantage which you will have whenever there is a symmetry present in the given density function curve. So that is the reason I have taken this model. Now see the remaining two questions, you can tell straight away. what is the probability that noise takes value between minus 1 into 10 power minus 4 means this point to 1 into 10 power minus 4 means this point. So this is nothing but 1 minus 2 into q of 1 over. And what about the third bit? What is the probability that noise takes value between 0 to 10 power minus 4? So between 0 to 10 power minus 4 means only this part. You know this total part. This part should be exactly half. So you divide this with 2. So that means this will be 0.5 minus q of 1 over. See how easily you got these values. So even if you can determine one part of the area, all the remaining symmetrical functions you can easily get it. That is the advantage with the Gaussian density function curves. So this model of question is very, very important for your competitive exams. All required points I have already given. Distribution function of a Gaussian random variable is 1 minus q of x minus mu by sigma. So that is what I have written here. So if you can remember these things, in seconds you can tell the answer. No need of even minute. Just reading the question will take time. Answering 5 to 10 seconds maximum. Okay? Right. Let's go to the next one. See here. Question related with the signal to noise ratio. A 1 milliwatt video signal means what is the data given to you? Power of the signal is given as 1 milliwatt having a bandwidth of 100 megahertz. So signal bandwidth means its maximum value. Generally we write it as W, which is equal to 100 megahertz, means 100 into 10 power 6 hertz. E is transmitted to a receiver through a cable that has a 40 dB loss. That means what is happening here? You have your signal and this is getting transmitted through a channel and then it is coming to a receiver. So in between you are having that channel. So your signal has a power of 1 milliwatt here, 1 into 10 power minus 3 in watts. Now this is getting attenuated by your channel because channel is said to have a loss of 40 dB. So 40 dB loss means what? Minus 40 dB is a gain. So 40 dB loss means 10 power minus 4 or not? If it is the amplifier 40 dB, 10 power 4. If it is attenuation 40 dB, 10 power minus 4. So what is the power of the signal by the time it comes to receiver? 10 power minus 3 multiplied by 10 power minus 4 is 10 power minus 7 watts. Finish. So this is the power of the signal once you have transmitted. This is the power of the signal once it is received at the receiver side. So generally whenever you transmit a signal through a channel, channel will have an attenuation. Attenuation means decrease in the power level. Sometimes channels will also have amplifiers. Amplifiers means increase in the power levels. Same thing you can tell there is an amplifier of 40 dB. So 10 power minus 3 multiplied by 10 power 4, it becomes 10 watts. Channel attenuated by 40 dB means minus 40 dB gain, means actual value will reduce. That's the reason you have this. Okay. Now, if the effective one-sided noise spectral density at the receiver is 10 power minus 20 watts per hertz, means what? He is saying that N0 value. Two-sided power spectral density means N0 by 2. Single-sided power spectral density means N0. E is given as 10 power minus 20 watt per hertz. So this is the distribution of noise power in frequency. That's the reason you see the units watts per hertz. Power of the noise distributed in frequency spectrum. If it is two-sided, you have to take N0 by 2. If it is single-sided, you have to take it as N0. Now, what is the power of the noise at input of receiver? Power of noise at receiver is always equal to that W into N0, bandwidth of the signal multiplied by N0. So obviously 10 power 8 into 10 power minus 12 will become 10 power minus 12 in watts. Finish. Watts per hertz multiplied by hertz. So the result will be in watts. Clear? Now what is the question is asking? Signal to noise ratio at the receiver is dash. So what will be your S by N? Signal power at the receiver side is 10 power minus 7 divided by noise power at the receiver side is 10 power minus 12. So this becomes 10 power 5 watts. Now question is in dB, so 10 power 5 watts I can write it as 50 dB. Finish. That's all. So your correct choice will be option So this is how you can develop the signal to noise ratios at the output of your receiver. So whenever you talk about this single-sided power spectral density or double-sided power spectral density, indirectly the meaning is the channel that you are considering here is a Gaussian channel. So for these Gaussian channels, you are given the distribution of the power in watts per hertz. So when you multiply that with your message signal bandwidth, you will get the power of the signal in watts. That is the meaning in this logic. Okay? Right. Let's see this one. It's also a very important concept. I am covering all the topics related with your random variables and random processes in this class. So instead of just taking the theory points and going through all the slides, it becomes quite interesting for you if you see that with an application, means with a numerical. So it will be taking the important point as well as getting the actual crux of that particular point using a numerical. So that is how actually I teach in my class also. So try to focus more on numericals, don't read any theory. You touch any textbook, immaterial, you take the best textbook or the local publisher textbook, does not matter. If you are reading theory means you are losing your competitive exam, because in competitive exam, whatever the exam you take, it might be the biggest exam or the smallest exam, does not matter. Examiner will focus on application. Application means solving numericals. So if you are interested, you take a standard textbook, simply remove all the pages, come to the examples or unsolved questions, do the questions and see whether you are getting the correct answer or not. That's all. Don't read any theory. Theory, whenever you want, you first do the numerical based on whatever the inputs you have. Then if you are having any doubt in that numerical, with respect to that particular numerical, you refer the theory part. Then the understanding will be clear. This is what IIT professors, even in NITs, they will do. The methodology for the student to understand the concept is this way. So it is reverse. Generally we think that first we have to go through the theory, then solve some examples, then solve some unsolved numericals, then attempt the paper. No. First is to solve numericals only. Then only you will get a very good grip on theory. So if you keep on studying theory, time will pass on and your exam date will come and you will have a very small grip on solving numericals that will never be sufficient. So that is the reason, try to focus as much as possible on numericals. Okay, right. Let us see this question. X and Y be two statistically independent random variables. So important point here is, you are considering two random variables which are given to you as independent, which are uniformly distributed in this interval. So what is the meaning here? Whenever you take uniform distribution means what? Probability of occurrence of the events between 2 points will be equal. So your X is a continuous random variable distributed uniformly in the interval from -1 to +1. So obviously this height will be, base is 2, height should be 1/2. That itself will be your density function over. And next, what is the other point he is saying? Y is also a uniform random variable. From where to where it is distributed? It is distributed in the interval from -2 to +1. So you draw a rectangular function from -2 to +1. And base is 3, so your height should be 1/3 for the area to become 1. That itself is your density function, 1/3, finish, over. Okay, now what is he saying? If z is equal to x plus y, what is the probability that z is less than or equal to -2? Very, very important concept. Whenever you are taking a addition or subtraction of random variables, then the density function of the resulting random variable will be always convolution of the probability density functions. This is the concept involved. So if you are adding two random variables which are independent, that is very important point. If x and y are independent random variables, then the sum of the random variables, when you are designating it as z, then the density function of z will be convolution of individual probability density functions. So if you do convolution of two step format signals, this width is 2 units, this width is 3 units. So different widths, whenever you do convolution, it will be a trapezoidal waveform. That concept comes from your signals and systems. Whenever you do convolution procedures, convolution is a very important topic in your signals. So if the widths of these two rectangular functions are same, then the convolved output will be triangle. If the widths of these two functions are different, then the convolved output will be trapezoidal function. So definitely your output is trapezoidal. So what will be the function here? So from where does the convolution start here? Convolution starts at the sum of lower limits, which is -3. So first to go to that point, -3. Now trapezoidal means what? You should have positive ramp, then you should have a constant, then you should have a negative ramp. Positive ramp will always come in the width of the signal having lower value. So width of this first signal is 3, width of this second signal is 2. So because the second width is smaller, you will have a positive ramp starting at -3 up to -1. How are we fixing that -1? Add that width with the lower signal, -1. When you add the width of this lower signal, which is 2 units to -3, it will be -1. So till -3 to -1, you will have a positive ramp. Then you will have a constant in the difference of widths of two signals. What is the difference in widths of two signals? 1 unit. Add 1 to this -1. Means up to 0, you will have constant. Then you will have again a negative ramp in the width of the signal having lower value. Lower value width is 2. So add 2 to this 0. So you will have a negative ramp from 0 to 2 over. So this x-axis is now your random variable z, and then this y-axis is your probability density function of the random variable z. Finish. Now what is your requirement? Only requirement is to find this height h. Now you know the total area of the density function is 1. So what is the area? You take this as one triangle, this one is one rectangle, this is another triangle. That means total area half into base is 2 units, height is h, plus rectangle area, base is 1, height is h, plus again triangular area, half into base is 2, height is h, equal to 1. Finish. So how much you are getting? 3h equal to 1. So the value of this h will be 1/3. So you will get this value as 1/3. That's it. Over. Now what is the actual question he asked? What is the probability that z takes a value less than or equal to -2? So probability of z less than or equal to -2 is integral from starting point -3 to -2 f of z dz. Finish. So what is your requirement? Your requirement is to find the area from -3 to -2, means this shaded region. -2 will be exactly this midpoint. So this is looking like one triangle or not? So exact midpoint. So because its total height, this value is 1/3, this should be 1/6. This is your -2. So this is again area of a triangle, half into base is 1, height is 1/6. So this value happens to be 1/12. Finish. See how easily you can get it. Definitely it will take 2 minutes. It will be greater than 1 minute only. But these model of questions are likely to come in your competitive exams. It's a very, very, very important concept. Whenever you take sum of independent random variables, the resulting random variable will have a density function obtained by taking convolution of individual density functions. Is it clear or not? So this is what we refer to as central limit theorem. So when these number of random variables which are independent are small, then no problem, you can do. If the number of these independent random variables are very large in number, that means you are taking 10 independent random variables, adding them, then the final random variable that you will be getting will take the form of Gaussian random variable. That is also an extension of this particular topic. So when 2 random variables are there, this is what the sketch you got. Similarly, you take the same format of such random variables, 10 random variables. So when you do on convolution, the final curve that you are going to get will take the form of Gaussian function. That is the meaning in this theorem. So keep this point in mind. It might be a theoretical question or it can be also a numerical. Numerical will be of this form. Theoretical, when you take a very large sum of independent random variables, then the final random variable that you are going to get will take the form of a Gaussian random variable. These are the points you need to remember whenever you are taking a addition of independent random variables. Let us see one more question. I think 5 more minutes is left over. 1 or 2 questions we will see. Again you see this concept, u and v be two independent random variables. So here again the same concept. He is concentrating on independent random variables. But the nature of the random variable is given to you. So what is the data? U is taking the form of a Gaussian random variable whose value of mean and variance is given. That means the expectation of u is 0 and variance of this u is 1 by 4. So whenever mean value is 0, mean square value and variance will be same, because you will get variance by taking difference between mean square value and mean square. So obviously when mean square becomes 0, mean square value and variance are same. So this will be 1 by 4. Similarly, other random variable is v, which is also a Gaussian random variable. Again the data is mean value of this random variable is 0 and variance of this random variable is 1 by 9. And obviously mean square value and variance will be same whenever mean becomes 0. That's all. Along with this, what is the other point? U and v are independent random variables. That's all. Now see what he is asking. What is the probability of 3v is greater than or equal to 2u? See how intelligently he framed the question. So what I am doing here is, I will take z, which is nothing but 3v minus 2u. So indirectly how I can write? What is the probability of z greater than or equal to 0 or not? That is the question or not? I am just converting the way the question is framed, that's all. 3v greater than or equal to 2v means 3v minus 2u greater than or 3v minus 2u I have designated as z. So what is the probability of z greater than or equal to 0? Now, if you are considering a z as 3v minus 2u, what is the mean value of z? It should be the mean value of this function 3v minus 2u or not. So you just expand that operator. Expectation of z will be 3 into expectation of v minus 2 into expectation of u. Expectation means mean values. Both the mean values are 0. That means the mean value of your random variable z is also becoming equal to 0. So what is the meaning here? We are considering z as a Gaussian random variable with a mean value of 0. That means your x-axis is random variable z and it is a bell-shaped curve centered about origin. So this is your f of z. Done? That's the reason I told you, whenever you draw Gaussian curves, you will get a better understanding on solving the question. Now, what is the question? What is the probability that z greater than or equal to 0? So, is it the area under this density function curve or not? What he is asking. So, if you take the total area of z greater than or equal to 0, this is a shaded region. Now, just by seeing, can you tell or not? Because total area must be equal to 1, this area must be equal to 0.5, 1 by 2, finish. So, your correct choice here will be definitely 1 by 2. So, just by understanding the given concept, you can easily get this value. Don't waste your time in doing all the other calculations. Try to focus on what actually he is asking. Then it becomes very easy for you to understand. And remember these values whenever you deal with Gaussian random variable. Standard density function is 1 by root 2 pi sigma square e power minus of x minus mu whole square by 2 sigma square, where x can take values from minus infinite to plus infinite. This is a density function for a Gaussian random variable. And what is its distribution function? I gave you as 1 minus q of x minus mu by sigma. Any competitive exam, you will not find a paper without this question. So try to remember this, okay? And remember these q function values, q of minus infinite, q of 0, q of infinite means very high value. Always a q functions is a decreasing function. So as x value increases, q of x value decreases. So q of minus infinite is 1, q of 0 is 0.5 and q of infinite is 0. More the value inside the q function, lesser is q of that value. And you can write a q of minus x as 1 minus q of x. So these are direct q function values. These will not be given by examiner. Directly you have to get this. So these are very important whenever you are considering the cases of Gaussian random variable. Either the questions will be framed with uniform random variable or they will frame with Gaussian random variable. And sometimes they will tell that they are considering a normalized Gaussian random variable. Normalized Gaussian random variable. So normalized Gaussian random variable means the meaning is the value of mean happens to be 0 and the value of variance happens to be equal to 1. So the density function of such Gaussian random variable we can express as 1 by root 2 pi into e power minus x square by 2. X can take any values between minus infinite to plus infinite. Okay, so this is also another way of indirectly giving you the data about mean and variance. So these are all the points related with Gaussian functions. So try to focus on these points, whatever the time that we have. I try to cover the important concepts of all the random variables, especially questions related with Gaussian and uniform random variable. So try to focus more on these areas and see formula based questions first and then go little bit in depth. That will help you to improve your confidence and do your question paper easily. So I wish you very best in your examinations. Try to focus every day, don't waste your time and try to do as many questions as possible with the minimum number of errors. Thank you.